This is the fourth video of the section 11.5, distance between a point and a plane. This is the plane and point is here. I say Q, X naught, Y naught, Z naught. Then we need to find this distance between point and a plane. I say that is D. So the equation of the plane is ax plus by plus cz plus d equals 0. So then find the p point. It is, I say, x1, y1 and z1. Then I get the pq vector. So can we find the pq vector? Yes. PQ vector is x naught minus x1, y naught minus y1, z naught minus z1. That is the PQ vector. Then we can find the n, what we call, this is the normal vector to the plane. So what is the normal vector? According to the equation, you see a, b, c, coefficient of x, y, z respectively. So we use a, b, c. That is the normal vector. You know, I explained this in the previous video. Right. Then I use d distance, and here is the same. I say this one. Right. So I say this is r. So PR is the same distance d, right? D equal PR. So what is the PR vector? Yes, PR vector is, you see, PR is the projection of PQ onto N, because you see this is N here and this is PR. So PR vector is the project PQ onto N, right? Right. Then we need to find the D. D is the same as magnitude of PR. All right. So first, let me write the project of PR onto N. What is that? PQ, project of PQ onto N. PQ dot N divided by a magnitude of vector n to power 2 times vector n. Right. So again, D equal PR magnitude. So this equal project PQ onto N and magnitude. So this equal, we can write PQ dot N is absolute value. This is N power 2. Then this we take N magnitude, right? Magnitude of N, because we take magnitude of the both sides. So that's why I use here. Therefore, according to this, we can say D equal PQ dot N. Then you see cancel out just one N. This equal N. So that is the D. Then we know PQ and N, so we can apply. So let me write over here D equal PQ. PQ is x naught minus x1, y naught minus y1, z naught minus z1, and dot N A B C divided by magnitude of N, which is a square plus b square plus c square square root. So you can simplify this. Then we can have a x naught plus b y naught plus c z naught plus d divided by a squared plus b squared plus c squared square root, where d equal negative ax1 plus by1 plus C, Z1. Next, distance between two parallel planes. Distance between two parallel planes. Right. So let me write P1 plane, plane 1, 3x minus y plus 2z minus 6 equals 0. And plane second one, P2, 6x minus 2y plus 4z plus 4 equals 0. Then how do we find the distance between these two? Let me draw like this. This is the one and this is the other one. So then what I do, I say this is P1 and this is P2. Then I find a point on here on P1, and also you can find the point P2 also. Then it changes according to that. Then I use this distance, that is the D, and that is the distance between two planes, right? These planes are parallel. Alright, so how do we find this point? What I do, I use y equals 0 and z equals 0. Then I plug this value to this equation. Then you will have x equal 2. Right? Therefore, we can say this point 2, 0, 0. What I did, you can plug any two values for any two variables and find the other variable according to those values. Then get the point that coordinate as a point of this. Now we know a point here and we need to find the n according to the above theorem I explained, right? N. What is the n? So n of this, right? N of this. So n equal a 6, negative 2, 4. Now go back to the explanation. You see here the distance between a point and a plane, right? Now the same, we can apply this to the distance between two parallel planes, because we find that we have a point on a one plane and we know the normal vector of the other plane, so we can apply this one to find the distance between two parallel planes, right? Therefore I can say D equal magnitude A equals 6, x naught is 2 plus negative 2, y naught is here 0 and plus 4, z naught is 0, and divided by a squared 36 plus 4 plus 16 square root, right? So then at the top we get 12 divided by 56 square root. So this is the distance between these two parallel planes. Next, distance between a point and a line in space. Alright, so let me draw the line, this one. So this is a line, I say L, and a point over here, I say Q. That is the point, right? We know. Then how do we find the distance between these? So this is the distance, I say D again, right? You know, when we know the equation of the line, we can find a point. So I say that is P. Then we can find the vector PQ vector, PQ vector. Well, we know this point, right? Q point. So I say that is x naught, y naught, z naught. So then how do we find the d? You know d is pq. If I use this is as a theta, okay, and let me use the direction vector. When we have a line, we use or we can find a direction vector, that is u. So then actually d is, we can say pq vector magnitude and sine theta, right? So how do we find this? PQ cross U is what? PQ cross U equal, actually this is a magnitude, therefore U cross PQ, because of magnitude these two are equal. This equal PQ time U sine theta. So you see PQ sine theta is D. Therefore, I can plug PQ here, U. I can plug D for the PQ sine theta. So then D, U. So then D equal PQ cross U divided by magnitude of U. So that is the distance between a line and a point in this space, right? So example, let me explain this. Find the distance between the point, I say Q, 1, -2, 3, and the line x plus 2 over 3 equal y over -2 equal z minus 1 over 4. Right. Now tell me a point on the line. Yes, according to this equation, we can say point -2, 0, 1. If you cannot remember this, please go back to my previous one of the previous video, so then you will understand. I explained this my previous one of my previous video. Right, here actually 2, then is become -2 because of positive, here 0, and here 1. So right, then what is the u vector? We know according to this 3, -2, 4, that is the u vector. So according to this theory, we need to find PQ cross U, right? So I do that PQ cross U equal I, J, K, right? So PQ is, so what is the PQ? You know we can find the PQ in this. Okay, the 1 minus -2, which is 1 PQ, right? PQ is 1 minus -2, which is 3, and -2 minus 0, -2, and 3 minus 1, 2. Right. And U is 3, -2, 4. This is -4i, then -6j. Now we know PQ cross U magnitude is 16 plus 36 square root. That is 52 square root. And we need magnitude of U, that is U is 3 to power 2 plus -2 to power 2 plus 4 to power 2 square root. That is 29 square root. From these two, we can say D equal root 52 divided by root 29, and mean root 52 over 29. So this is the distance between the line and the point Q.